What's up, y'all? My name is Mr. Canada and welcome to my math domain. In this video, we're going to be talking about how to multiply polynomials and the techniques that we have to keep in mind in order to be successful with multiplication. We are going to look into several different types of examples that you might see in an Algebra 1 course. So without further ado, let's go ahead and get started. So multiplying polynomials is going to rely on the use of the distribution property. Basically, the idea is that you take a number on the outside, right? And you're just going to distribute it. You're going to multiply it to all the terms on the inside of the parentheses. Now, you guys have done stuff like this before. You've used a distribution property whenever you were solving an equation, anytime that you were trying to simplify an expression. We're going to be using that exact same tactic with all of the problems we do in this video. There's just going to be a very, very small twist to the distribution property that we're going to perform. And that twist is that we're going to be not just distributing a number, but we're also going to be distributing a variable. So let's go ahead and get started and see how distributing a variable is going to be not so bad with a lot of the examples we're going to see here. So look at this first example. So we have 2c squared times c squared minus 4. So this is an example of multiplying a binomial by a monomial. So the idea that we're going to try to apply here is that we're going to take this quantity on the outside and we're going to distribute it. We're going to multiply it to the quantities on the inside. So I'm going to show you step by step how that kind of looks like, and then we're going to simplify it afterwards. So here's how we're going to do it. We're going to multiply c squared by 2c squared. So c squared times 2c squared. Next, what we're going to do is multiply this negative 4 times again 2c squared, because that's the term that we're distributing by. So notice what we have after we distribute 2c squared into both of these terms. We have a little bit of a mess here, so it probably would be a good idea to simplify what we have. So c squared times 2c squared. Well, first of all, the coefficient is just basically 2 times 1, so we're going to end up with 2. But then the c squares will simplify by simply adding the exponent. So that's going to be c to the 4th power. Now over here we have negative 4 times 2c squared. Well, negative 4 times 2 is negative 8. And we're just going to copy along that c squared. And this right here is the expression you have left over after you multiply and simplify the term on the outside to the two terms on the inside. So it's not a lot of work to it. Really, all you have to keep in mind are an exponent property here and there, and definitely being careful when multiplying some coefficients. Let's go ahead and see that again, but now let's look at something that's a little bit bigger. So here we have negative 3n squared times 2n squared plus 3n minus 4. So now this time we're multiplying a trinomial by a monomial. So how do we do this? Well, a lot like how we did the previous example, what we're going to be doing is taking this term on the outside and distributing it and multiplying it to the terms on the inside and see what we have left over. So let's go ahead and take it one term at a time so we can kind of visualize the numbers. So the first thing we're going to multiply is 2n squared with the term on the outside. So 2n squared times negative 3n squared. I'm going to go ahead and put parentheses around the part that I'm distributing by, just so it helps me visualize any type of negative integers. You could have also done this with the previous example and put parentheses around the 2c squared, but you don't necessarily have to. But I definitely recommend it anytime you're planning on distributing a negative number. Let's go ahead and go to the next one. So 3n times negative 3n squared. So 3n times, again, negative 3n squared. And then finally, negative 4 times negative 3n squared. Again, this looks like a complete mess, but let's go ahead and start simplifying. So simplifying this first piece, we have 2n times negative 3n to get us, negative 6. And then adding the exponents of the n's will get us n to the power of 4. So that's this piece. Simplifies to that. Oops. So now let's move on to the next piece here. We have 3n times negative 3n squared. So 3 times negative 3 is negative 9. N and n squared, adding the exponents of those two variables will get us n to the power of 3. And then simplifying the last term, we have negative 4 times negative 3, which is positive 12. And we're just going to copy paste that n squared. So this is the expression we have left over. Negative 6n to the fourth power minus 9n to the third power plus 12n to the second power. So notice that there's not really a lot to these problems. Really, what we have to keep in mind is what are we multiplying by, simplifying it carefully, and making sure that we correctly add any of the exponents of the variables, if it's possible. Now, like I said, this isn't the only type of examples that's related to multiplying polynomials. You might also have an opportunity to multiply a binomial by another binomial. So let's go ahead and talk about those examples next. One thing that I do want to say is there is a lot of kind of contention about how to multiply two binomials, depending on who your math teacher is. So I'm going to go ahead and say both. So some math teachers prefer to teach the FOIL method. If you've heard of this method, basically the word FOIL, which I'm going to go ahead and write down here on the screen, is an acronym for how you're going to be multiplying your numbers. The F in FOIL means you're multiplying the first terms of each grouping. The O means you're multiplying the outer terms of each grouping. The I stands for the inner, and then the L stands for the last. So the idea behind FOIL is that it's a sort of an acronym to sort of help us out knowing what to multiply next. But on the flip side, some math teachers really dislike the word FOIL because I think in their opinion it kind of removes sort of the technique, the skill that's behind FOIL. So you might also hear FOIL being referred to as double distribution. And no matter where you fall on the line of FOIL or double distribution, in reality, they're both really the exact same thing. Generally speaking, the reason why they call it double distribution is because we're just going to simply be applying the distributive property 2 times. That's about it, which really FOIL is there to kind of help us know that we're doing that. So for the sake of these examples I'm going to show you here on the screen, I'm going to be using double distribution, but I'm also going to be referring to FOIL along the way as we're multiplying. So you kind of see it from both perspectives. And you're going to see at the end that really it is the same thing. So let's go ahead and start with that first example. So we have x plus 3 times x plus 2. So how do we start multiplying something like that? Well, keeping in mind with this idea of double distribution, what we're going to be doing is first taking this first term, the x, and we're going to be distributing it to the 2 terms in the other binomial. In reference to FOIL, with respect to FOIL, by multiplying this x to the x into the 2, you're actually getting the f and the o in FOIL. Because x times x are the first terms, x times 2 is the outer terms. So, regardless of how you look at it, let's see what we have left over when we multiply x with x and x with the 2. So, x times x, well that's just, well, I'm going to write it out, x times x. X times 2, I'm going to go ahead and write that out, so 2 times x. And just like that, we have already 2 unsimplified terms. This came from distributing x to this x, and this guy came from multiplying x with the 2. Now this is where the double distribution part comes in. What we're going to be doing is doing the exact same process again, but this time with the second term of the first binomial. And we're going to go ahead and distribute it to the exact same 2 terms in the second grouping. So the idea behind this is that when you use the FOIL method, that's how you're going to get the I and the L. 3 times x represents the inner terms, while 3 times 2 represents the last terms of the FOIL method. So 3 times x, well I'm just going to go ahead and put this 3 times x. We'll worry about simplifying after. And then 3 times 2 will just be, well, 3 times 2. If you already have the answers in mind, then perfect. I'm just taking a step at a time. So, just like this, whenever we multiply a binomial, notice that we have 4 distinct pieces here, right? We have 4 unsimplified pieces, as a matter of fact. And again, you can get this by applying the distributive property twice or using FOIL. And you're going to notice that you're going to get the exact same things. This is the F, this is the O, this is the I, and this is the L in FOIL. So now what do we do from here? Well, all we have to do from here now is kind of just simplify and see what we have left over. So right now it's in Christmas color, so I'm going to go ahead and ruin that. So x times x is x squared. 2 times x is 2x. 3 times x is 3x. And then 3 times 2 is 6. Now from here we can continue simplifying the expression by adding 2x and 3x. So let's go ahead and do that. By combining 2x and 3x, we're going to have 5x. And we're just going to simply bring down the plus 6 and the x squared. And this right here is the expression after multiplication and simplification. So the idea behind FOIL and double distribution is basically the same thing. Some people prefer using FOIL, so if you're comfortable with that, then go ahead and use FOIL. If you think double distribution is easier, like you've never heard of it or never thought of it that way, then go ahead and use double distribution. But regardless of which method you choose, go ahead and choose a way that you feel the most comfortable with. I'm just here to kind of show you both sides of the coin, of the same coin. Let's go ahead and do it again. Let's go ahead and do it with 2x minus 5 and 3x plus 2. So let's go ahead and take this 2x and let's multiply it to the 3x and let's multiply it to the 2, okay? So 2x and 3x, I'm just going to go ahead and write that out just to kind of help us visualize what we're multiplying by, especially if we're doing FOIL. 2x times 2. And we got the first half of our answer. Now let's get the second half. To get the second half, we take the negative 5, and again we multiply it to the two terms. So we're going to have 3x times negative 5. Again, I'm putting the parentheses here just because the negative is there. And then 2 times negative 5. If you're following FOIL, this is the F in FOIL, the first terms of each grouping. This is the O in FOIL, the outer terms of the groupings. This is the I in FOIL, the inner terms of the groupings. And then this is the L of FOIL, the last two numbers of each grouping. So now let's go ahead and simplify. So 2x times 3x. Well, if we multiply that, we're going to have 6x squared. 2x times 2 is going to be 4x. 3x times negative 5 is negative 15x. And then 2 times negative 5 is going to get us negative 10. Again, we can combine the like terms here, 4x minus 15x. So 4x plus negative 15 will get us negative 11x. And we bring everything else down. And there you have it, 6x squared minus 11x minus 10. Let's go ahead and do another one. This one's a little bit special. So x minus 5 to the power of 2. One thing that you have to keep in mind is that notice that with our expectations so far, we should be able to apply FOIL or double distribution with this type of example. But the problem is that we don't necessarily have two binomials at the moment. One thing that you want to kind of remember is that the exponent tells you how many times you're going to be multiplying the base. In this case, the base that we're working with is x minus 5. So, one of the first things we have to do is expand x minus 5 to the power of 2 as the following. Basically what we're going to be doing is writing x minus 5 2 times. And the reason why it's 2 times is because the exponent is 2. Now, here's what you don't want to do. And your math teacher might have also talked about this as well, so I'm going to go ahead and talk about it. And in case they haven't mentioned it, let me mention it now. We might be absolutely tempted to do this. When we see something like this, we might want to do this because it's so tempting. X squared minus 5 squared. Be careful with doing something like this. Yes, you're absolutely right that this is an exponent property that does say that we can distribute the exponent of 2 to the exponents on the inside of the parentheses, but that's only true if there is an operation of multiplication on the inside. Anytime there's addition or subtraction, we are not allowed to distribute the exponent to the exponents of the terms on the inside. So please be careful about that. Some math teachers call that a sin, complete blasphemy, but keep an eye out on that property. You're not allowed to just distribute the exponent. What you are allowed to do, though, is expand it out so that you have the opportunity to use FOIL or double distribution. So let's go ahead and do that real quick. So again, let's go ahead and start with the first term here. I do apologize, my tablet's acting kind of weird. So let's go ahead and distribute the x to the two terms. I hope you guys don't mind if I go ahead and quickly go into the multiplication already. So x times x will be x squared. X times negative 5 will be negative 5x. So that's our first half. Let's go ahead and get our second half. Negative 5 going to be multiplied again to both of these terms. So negative 5 times x, well, that gets us another negative 5x. And then negative 5 times negative 5 is positive 25. And just like before, we can add the two like terms in the middle, negative 5x plus negative 5x, to get us a nice and clean negative 10x. And then we bring down everything else, 25 and then the x squared. So this right here is our answer. So keep an eye out on this one, y'all. If you have a single binomial but it's being raised to the exponent of 2, go ahead and write that binomial twice so it gives you an opportunity to do double distribution. Let's go ahead and recap what we talked about in this video. In order to be successful with multiplying polynomials, all you really have to do is apply the distributive property. Keep in mind that whenever you're multiplying a binomial by another binomial, you could either use the FOIL method to kind of keep track of what you're multiplying by, or if you think it's easier to think about double distribution, you can do that as well. But at the end of the day, they're really the same thing. The only thing you have to be careful about is make sure that you multiply your positive and negative integers correctly, and definitely keep an eye anytime you're distributing a variable with exponents. Remember, at the end of the day, the total number of exponents should be increasing for each term. Well, I hope you guys learned something new today. If you have any questions, leave them in the comments below and I'll try to get to you as soon as I can. If you liked the video, give the video a like, get subscribed to my channel for more Algebra 1 videos. And as always, please take care, and I'll see you guys next time.